Hi and welcome back. In the current series of Java Bootcamp, we have just made a single video where we have created our first program. So that program was very simple, where we understood like how to write our main class and what is a main method. Now when you are running this program, in that process of running, you first compile it and then you execute, or we say the Java is interpreting your bytecode. Now this is a very simple line that Java compiles your program, converts it into the bytecode, and then bytecode is sent to the hardware by interpreting it. But when we want to go into deep dive of this, like what actually compilation means and what is the interpretation, and also along with this we'll understand what is the meaning of platform independent, why Java is called as platform independent. So let's start with today's topic. So as we wrote our last program, we'll call it as a Java source code, right? And that is a file which was written as hello world dot Java. So this .java is the extension of the file which you have saved it. Now when you are going to pass it to the compilation, right, or the compiler, so we say, okay, Java compiler, let's compile the file. Now when there is a compilation process, it checks your file for all the syntax rules, right? Whether you have applied all the rules or not, or you are missing any of the syntax, like are you missing a semicolon, you are not terminating the parenthesis, right? So all those kind of errors will be looked for, and if it finds any of the error, right, it will fail the compilation. So what is the criteria of compilation to be successful? It should not have any syntax errors. So when I say syntax error, means you should not miss your parenthesis, or you should not miss a terminator symbol. For example, let's suppose if I have opened this parenthesis, but I have not closed it at this point, and then you will get a compiler error. Let's quickly check the compiler error also. So I'm going to compile this program. Let's go to the terminal, Java C and hello world.java. Now if I run this command, it will give me an error. The reason is the parenthesis is open over here and I have not closed it at this point. I have done it knowingly, right? But sometimes when you are new in programming, you are learning Java, like you are a very new learner. So at that time, these kind of mistakes will happen. So don't worry, your compiler will immediately point out, and when you will move to IDE will immediately show it that, okay, the parenthesis is not closed at this point. In fact, they sometimes auto-complete it as well. Okay, so let's run this, and you see now it's giving an error. It's saying reach end of the file while parsing, and it's giving some indication that there is some parenthesis should be there, or it's not closed, or there is an extra parenthesis, right? So you have to just do not rely on the word of this error. You have to look for the error at line number 8. So let's go to the line number 8, and we see that, okay, there is a parenthesis, but we are missing one. So we have to add that parenthesis, right? So compiler will see that file is completely okay. There are no syntax errors, no rules error, rules are not missed. So if it does not find any error, it will compile your file and it will create a dot class file. So let's run it now, and compilation is successful. That means it has created up a dot class file. Even if the dot class file is already existing, right, you make any changes, you have to recompile it. You have to compile it again so that the changes can be compiled and a new class file is created. Okay, the previous class file would be overwritten. Compilation is good. We understood that a source code will be converted into the machine understanding code, but here in Java it is creating up a middle level code, right, which is called as bytecode. We are calling it as a bytecode, right? Now who is going to understand this bytecode? Is it the hardware? So the answer is no. Hardware will not understand the bytecode. When I say hardware, I mean the processor, right, your other parts in your CPU, right? Or let's suppose if you want to write some data on the hard disk, so your hardware is not going to understand it. unless and until the instructions are given in the binary format. They will go to your CPU will be passing up the instructions to the complete system, right? So who is going to understand this bytecode? Now, bytecode would be understood by the Java itself. So Java is saying that, okay, don't worry, I am bringing up a new program, right, which will actually understand this bytecode. Fine. So let's go and create up. Okay, so let's call it as JVM. Right. So this JVM is going to read your bytecode. So whom am I going to pass the bytecode? Bytecode will be passed to JVM. Now JVM is going to read this bytecode. It is going to convert it. It is going to pass it to the hardware. Right. So when I say it is passing to the hardware, that means it may have converted it into the binary form. So now bytecode is read by JVM, and this JVM would be in Java runtime environment. So collectively we'll call it as the JRE, and when I'm saying the compiler, it comes in the JDK, Java Development Kit and Java Runtime Environment. So whenever you are installing Java on your system as a developer, you have to install both Java Development Kit and Java Runtime Environment. So once you develop the application and you want to give it to your client, so client don't require the JDK, right? Because he's not going for development. He only needs to run the Java application. So there we are going to install only the Java Runtime Environment. So now this JVM Java virtual machine will be reading the bytecode and it would be interpreting it. Right? So it is going to interpret the bytecode. Once it interprets the bytecode, it is going to pass the instructions to the hardware. Now, unlike compilation, interpretation will be done line by line, right? So suppose if there are 100 lines of code, assume like I have this code which is like having 100 lines of code. When I say 100 lines of code, consider it from the main method, not from the start of the file. So from the entry point, okay. So let's say my main is starting over here and main is of 100 lines. So from the first line, not the zero line, the first line, it is going to read the code from the bytecode and it is going to pass the instruction to the hardware, right? So now if let's suppose in the line by line execution, there is an error raised at the line number 45. Okay. So the line number 1 to line number 44 would be executed. The line number 1 to line number 44 would be executed. It will be run. It will give the output. It will take the input, whatever instructions you have written. But on line number 45, if there is an error, right? Let's say an error which occurred due to the user input, like you tried to divide it by 0. So dividing by 0 is a infinite value. So that can be an error. So now that error will terminate your program. That means your line number 1 to line number 44 has been executed, right? But line number 45 got an error, and then that's why the program is terminated. So rest of the lines of code will not execute. That is interpretation line by line execution. So the moment you get an error, it will stop executing the program. It will terminate it, right? But in compilation, it is going to read the complete file. If there are 100 lines of code, it will read 100 lines. Any one line has an error, it will not compile it. Okay, it will not compile 99 lines and it will leave one line. No, compilation means all the content of the file should be error free. It will compile it, it will convert it into the bytecode. You pass the bytecode to the JVM, and then JVM is going to interpret it to the hardware. I hope this is good. Now, let's talk about what is inside the JVM, right? How is JVM checking this bytecode and then converting it into the hardware code? So now let's say I got the bytecode. Okay, let's say this is the bytecode, which is a .class file, right? Which is a .class file. Now this bytecode will be passed to the JVM. This bytecode would be passed to the JVM. Now JVM is going to do some checks on this, right? So first it is going to load the class. Load the class. The class that you have given to the JVM will be loaded, right? It would be loaded into the memory, or we can say it would be loading up some data from that class. We will discuss about this, that what kind of data will be loaded when a class is loaded, right? When a class loader run. So here we have the loading of the class, which is done by the class loader, right? So this is the first step. When JVM is called and bytecode is given to JVM, JVM will first load the class. Okay. Now after loading the class, it is going to verify the bytecode, right? It is going to verify the bytecode. Now there can be a mismatch of the bytecode. Might be your JDK and JVM, JDK and JRE versions are separate. You compile the version on, let's say, 8.0, and then you are executing it on some earlier version. So that kind of bytecode verification would be done. Also, if bytecode is kind of not valid, right? So verify bytecode process will be done, and after that it is going to convert it into the code which hardware can understand, right? It is going to convert it into the code which hardware can understand. So now here you will again have one more compiler, which is called as JIT compiler. JIT compiler. I'll write its name, just in time compiler. Now you will think like so many number of compilers are coming in the Java program. So yes, one compiler is converting your source code into the bytecode. Then bytecode is read by JVM, right? And JVM is going to interpret it. So in this interpretation process, here comes your JIT compiler, which is interpreting it, right? So there is still only compilation and interpretation, but interpretation is done by the JIT compiler, just-in-time compiler. Okay. Now this just-in-time compiler would be reading that code line by line and passing it to the hardware, right? Here the journey ends of the code, so it is passed to the hardware. So this is a line by line. It will read, like for example, let's say in my code I have given system.out.println hello from Java Bootcamp. So this line will be sent for the interpretation. Next, suppose if I write let's say bye. Okay, so I'm writing a hello and a bye. So now the first line will go for the interpretation, second line will go for the interpretation. But assume if in this place I had done some work, like let's say 10 divided by 0. Assume I was doing some calculator program. I was writing some calculator program. I was asking input from the user. So user gave two inputs like 10 and 0. So now this can raise an exception. If I'm running this program, my hello from Java Bootcamp will run, 10 divided by 0 will run, but it will give an error exception, and therefore the program will be terminated. Let's try to see this. Okay, before compiling, if someone is having a question in mind that why compiler cannot check this thing, right? Why compiler cannot check this thing? See, compiler is going to check the rules. It is not going to check your data. It is not going to check your programming logic, right? It will only check the rules, which would be standard for all the Java developers. Breaking your problem with a different logic can be different for different developers. So in that case, Java is not going to check your data. Java is not going to check your logic part. That is the part of your execution. So when execution is having mismatch of the data, you were expecting a input of, let's say, a string word, and you got a integer value, right? So these kind of things come under the execution part. So let's compile this program. Compilation is good. Let's go back to the program. Compilation is good. That means all these 3 lines of code need to be sent to the JVM. Let's run this. Hello world. So if you see, the first line is printed. That means line by line interpretation. First line is printed. Second line gave an error. So it is saying arithmetic exception, divide by 0. We will read about the exceptions in the later part of this course. It is a very detailed course. Don't worry. All the aspects of Java programming will be covered in this course, right? So if anyone is having some doubts on what is arithmetic exception, don't bother about this right now. It is just an error. Think it like as an error only. Okay. So now what is the solution for this? You have to take care of this line of code. Either right now I'll remove it, right? But when I'll go to the exception, I'll explain how to handle the exceptions. So for now, we are only going to remove. We are going to keep our program error free, that all the lines should execute. So again, since I have made the changes in the program, compile it. Compilation will create a new class file. Load the class file. Bytecode verification will be done. Passed to the just-in-time compiler, and the code will be passed to the hardware. Hardware is going to print on my terminal, hello from Java Bootcamp. Next line, bye. We are not going to do a bye right now. A little bit thing more we have to do in this video. Okay, let's remove this. Bye for now. Go back to the whiteboard. So bytecode is passed to the JVM. JVM is loading it, verifying it, passing it to the just-in-time compiler. Just-in-time compiler is compiling it, interpreting it and passing it to the hardware. What's next? So we understood the process of compilation and interpretation, right? So I believe anyone who is in college and like in first year of your engineering, second year of your engineering, and you are talking about compilation and interpretation, so you should be very much clear about this process now. Now let's talk about how Java is going to be a platform independent, right? That's a very big buzzword about Java. Platform independent, right? What is platform independent, right? First of all, let's understand what is a platform. Platform if I talk about my daily life, what is a platform? I'll say, okay, platform is something on which we can stand, or we can keep something on a raised platform, right? So same way, your Java program is also running on a platform. Okay, so the first thing that comes in your platform is hardware. Okay, hardware. Now let's suppose if you are using up Intel chip, right? Or you are using up a AMD chip, or you are using up, let's say, M1 processor of Apple. So there are different hardware, right? Different hardware, different CPUs in market. So this is part of your platform hardware. On your hardware, you have the next platform, that is your operating system, right? Now see, the complexity of hardware is hidden by the operating system, right? So if I say I am writing up a programming language and I don't want that I have to write 4 versions of programming language for 4 different type of hardware in the market. So I'll focus on the OS. I'll say, okay, there are only 2 major OS or 3 major OS, like Linux distribution, the Mac OS, and the third one is Windows, right? So I am going to focus on these 3 OS if I'm writing up a new programming language. But then Java was thinking a step ahead. They said, why should we write 3 different versions? Why should I write 3 different versions for different operating system, right? So they brought one more layer of platform, right? One more layer in this platform. So now they are making this as a combined one platform. So here they are saying, let's have another layer, which I will call as a Java, in short, Java runtime environment, which we have seen few minutes back. So Java runtime environment. Now, how is this Java runtime environment going to make it platform independent? Your Java program, right? So let's say I want to run a Java program on my system. Let's go to the terminal. I am running a Java program on my system, right? And I have a Linux based system. I am running on Ubuntu OS. Okay. And my chip, the processor is a i5 processor. So now Java program is not going to bother about this thing, like whether it is a Linux or it is a the Intel chip, or let's say Apple chip, or any other chip, right? So it is not going to take care of all those things. It is just looking that, okay, since this is a Java program, is there a Java environment? Yes. So I'm going to execute it, right? So when I'm saying Java program, don't consider your .java file. Java program means now the class file. Okay. or we will call it as a bytecode. So your bytecode is going to look for the Java environment only. Fine. Now let's suppose if I upload this .class file. If I upload this .class file and I give it to all of you, that okay, you can run this file and you can see the output. So the point is, I'm only giving you the bytecode. I'm not giving you the source code. So if you get the bytecode, let's see the scenario, another scenario over here. Right. So what I'm doing is I have the hello world bytecode, right? Which is a okay, hello world dot class file. So this is the file I will give to my students, right? Assume that this is the file which I'm going to give to my students, that okay, run this file using Java on your system and then check what is the output. So now students can have different operating systems. Suppose there is one student who is working on Linux. Fine. So because my system is also Linux, his system is also Linux, I expect that the program will run on his system. Okay. The another user is having a different operating system. Let's say it is Windows. And the third user is having a different operating system. He is having a MacBook. Okay. Maybe someone else is coming with server operating system, that is Solaris. Okay. So now in this case, my hello world bytecode was created on Linux. Will it be executed on Linux, Windows and Mac OS system? So answer is yes. Right. Now why it is running on all the systems? Why I should not give the source code, right? Why I should not bother the students that okay, take the source code, compile it again, make it compatible to your system. So these all things are not required with Java. Your bytecode is already compatible with all the operating systems, right? The reason is, let's remove first of all these few boxes. I'll then draw it again. Right. Now let's go for the reason. What is the reason? I'm giving the bytecode, right? The student is having a Linux system. Then student is having a Windows OS. Another student is having the Mac OS. So what is bytecode going to look for? Is bytecode going to look for the operating system? Answer is no. Bytecode is going to look for the Java runtime environment, right? So here you need to install a Java runtime environment, which is for the Linux OS. You need to install the Java runtime environment for the Windows, and obviously that would be already there on your system, right? So when you are going to learn Java, you have a Windows system, you are going to install the JDK and JRE, you already have that Java runtime environment. So bytecode is only going to look that whether there is a JRE, no matter whether it is of Linux, Windows or Mac OS. So this makes your Java as a platform independent. You can write once, create your bytecode, create your class file, and then you can distribute it, right? Suppose you are going to work on a project, you are working on an open source project and you released your project, right? You created some library and you released it. So you don't have to release 3 versions of that library or 4 versions of that library for separate for Linux, separate for Windows, separate for Mac. You can simply go create your bytecode. You can give it as a zipped archive, and anyone who is aware of how to run a Java file can execute it on Linux or Windows or Mac OS. Single version working on all the 3 OS. So that is going to make the bytecode, the Java programs as a platform independent. I hope this second topic of today is also good for everyone. Now, one important point we are going to discuss. In the last video, when we created this class, the file name and the class name were kept same. What actually is the reason? Now see, if I talk about the standards, we'll always consider that let's keep the file name and the class name as same, right? Now, being a newbie, sometimes you can think of, okay, that means I can write only one class in one file. So the answer is no, you can write multiple classes in the single file. But why do you need to write multiple classes in a single file? at this level, right? Maybe in advanced part you would write, but right now you don't have to write multiple classes in a single file. So write one class in one file, keep the class name and the file name same. Now let's come to the reason and the rules. Okay, so when you are writing up your class name, if your class is public, and when I talk about the public word, that means anyone can access. At any level, anyone can access. Now, who is this anyone? Ignore it for now. We'll come to the that part later. So now this is a public class, right? Public class will not have any limits. Anyone in this project can, any other class in this project can call this public class, right? Or I should define it like this, that if there is a public class, other classes can call it. Now, public class should always be defined in the same file name, right? Public class must be saved in the file with name same as class name. Okay, so in short, public class name should be equal to the file name, right? So public class name should be equal to the file name. That means if I am writing a public class hello world, the file name should be also hello world. Let's go and make a small change over here. Let's rename it to hello world 1. I have only changed the class name. Now see, my editor is also giving me an error. Let's hover the mouse here and it says the public type hello world 1 must be defined in its on file. So that means public class will always have a file with its on name, right? So either I go and change the file name or I change the class name. So very simple. Public classes should be saved inside the file name, which should be same as the class name. Okay, so if there is a public class, can I create more classes? Yes, you can create more classes in this same file, but they all should be non-public. So let's write up a class over here. I'll call it as a demo. Okay, class demo. I'm just writing up a blank class. And don't write multiple classes with the main method inside a single file. That is not possible. It's not required. So class demo. Now if you go and compile this file, let's remove this hello world.class. Okay, now there are two classes. If I want to compile, what should be the file name? I mean, what should be the name with which you are going to compile? The file name. Okay, so Java C hello world. I have two classes. But if I want to compile it, I have to look for the file name, right? And there can be multiple classes inside a single file. Only one class can be public, rest all will be non-public. Okay, so let's run this. Compilation is good. Go back to the editor. Now you can see there are two class files, right? Right now I am saying class files and class files. As we proceed with the course, I'll be not saying them as class files. I'll call them as class. So we have a hello world class and a demo class generated. See, there is a demo class and hello world class. That means if I am writing multiple number of classes in my file, in my source file, I will be generating up, or Java would be generating up that many number of the classes. Okay. So right now this is not required. I can remove it because we have not yet studied how to use multiple classes. We'll come to it very later. And so this is my one class, public class hello world main method, and inside this main method I am getting some instructions. So save this, go back to the terminal, run it, Java hello world, and the output is there. So in this session we have understood three things. The first one, how a Java program is compiled and interpreted, or what is happening behind that compilation and interpretation. Second, we have understood why Java is a platform independent language. If you are creating up your programs in Java, you can run them on any operating system because every operating system is coming with its own version of JRE, right? Which is acting as a platform for your Java code. Third, what about the public class? Public class should be saved in the file with the same name as the class name. You can write more than one classes in your file, in your .java file, but only one of them can be public, or you can keep like none of the classes as public. Remember, only one class is public and other classes is non-public. So that's all for today's video. Thank you everyone. Please share these videos with your colleagues who are learning Java, right? If anyone who is switching to Java stack, Java technology can go through this bootcamp. We would be trying to share a video every day, right? At least 4 or 5 videos in a week. So target is to complete in within 2 to 3 months, right? Okay, that's all for today's video. Thank you everyone. Bye.